Hello. In this video, we're going to apply the ideas of vectors and tangent vectors to physics. More specifically, we're going to talk about the motion of objects in space. So let's suppose we have an object that's traveling, and R of t represents the position of that object. So R of t is the position, and it travels along the curve like so. So at time t, it might be here, and then at later time t plus h, the position would be described by this vector here. We can look at the difference vector, r of t plus h minus r of t, and this would be the displacement vector, or the change in position. So this would be the displacement. And then we can also look at a difference at the quotient r of t plus h minus r of t divided by h. So what that represents, it represents the change, the displacement over time. So it gives you the average velocity of the object over the interval from t to t plus h. Now, because we're taking calculus, we want to make h go to 0. And so we want to talk about the instantaneous velocity, or the velocity function. So we want to take the limit as h approaches 0 of r of t plus h minus r of t divided by h. And we know that if this is defined, represents the derivative, r prime of t. And it also it represents the velocity function, v of t. It's the instantaneous rate of change of the position over time. So this is the velocity function. So what we know is, so we can conclude that thus the velocity vector is v of t, which is the same thing as r prime of t. And we know that this is, because it's r prime of t, is tangent to the curve at t. So I'm going to represent it in pink because I like pink. So here's the point, and here's the velocity vector would be tangent. So this is r prime of t, or the velocity vector. Like so. Now the magnitude of the velocity vector is the speed. So we have the speed. Oops, go back to white. So the speed is defined to be the magnitude of the velocity vector, or the magnitude of r prime of t. That's the length. And it's also the rate of change of the arc length with respect to time. So that's the speed, which we can also write it as s prime of t. And in physics, we also talk about the acceleration vector. So the acceleration is the derivative, we're going to call it a of t, is the rate of change of the velocity with respect to time. So it's v prime of t, or we can call it, it would be the second derivative of the position with respect to t. Okay, so let's take a look at a few examples. So one example, let's find the velocity and acceleration given the position. So suppose the position of an object is given like so. So it's square root of 2 times t, e to the t, and e to the minus t. And there are two parts to this problem. One is to find the velocity and the acceleration, and then to find the equation of the tangent to the curve when t is equal to 0. Okay, so let's do the first part. So we're going to write r of t. So r of t is equal to square root of 2t, e to the t, and e to the minus t. So we're going to differentiate it. So if we differentiate it, we get the velocity. It's going to be square root of 2, e to the t. And when I differentiate e to the minus t, I get minus e to the minus t. And then the acceleration vector is the derivative of the velocity. So let me make it a little. Oh. There we go. So the acceleration would be the derivative of the velocity. So 0 for the first component, e to the t for the second component, and e to the minus t because it's another negative for the third component. So that's the first part. And now we want to find the equation of the tangent to the curve when t is equal to 0, right? So what do we need to know, right? So what do we need to know? So that's the first part. So now the curve t is equal to 0. So the direction, so the tangent at t is equal to 0. Well, what's the direction? Direction of the tangent is going to be in the direction of the vector r prime, the velocity vector, at 0. So r prime of 0, we already, or the v of 0. And we have that direction because we can go above and compute it. It's over here. So it's going to equal square root of 2, 1, and minus 1. So that's the direction. And it needs to pass through the point. We need to like shift that. So it needs to pass through the point given by r of 0. So r of 0 is going to be when t is equal to 0, we're going to get 0. E to the 0 is 1, and e to the 0 is also 1. So our curve needs to pass through this point, and it's got to have this direction. So then the equation of the tangent, I'm going to write it in vector form. So it's going to be, I'll call it L for line, L of t is equal, so it's going to be the position vector, r of 0 is equal to 0, 1, and 1. So 0, 1, 1 plus the vector r prime of 0, square root of 2, comma 1, minus 1 times t. And we could separate this into components. First component is square root of 2. Second component is 1 plus t. And third component, oh, sorry, I think I made a mistake for the first component. So anyways, third component is 1 minus t. And let's fix the first component. So the first component is actually equal to square root of 2t. Okay. So that's how you get the equation of the tangent as well.